Testing, testing. I'm just doing a sound check. Adriana, could you hear me? I'm just doing a sound check. I want to make sure that everything is fine and that you could hear me and you could see my screen. Could you hear me, Adriana? Could you see my screen and could you hear me clearly? Okay, thank you very much. Thank you very much. Okay, so we're going to start the broadcast in a few seconds. And thank you all for attending today's webinar. Thank you all for attending today's webinar. I am David Millington, your host and Director of Education for Next Level Purchasing Association. And today we have a webinar of very critical and strategic importance, I'm sure, to all of you and to your operations and your organizations, looking beyond price for cost reduction and cost reduction opportunities. So the scope of the webinar, we would learn to unmask non-value added waste in your systems and your processes. We'll also learn to quantify the impact of process waste. And we would learn how to leverage cost reduction mechanisms. And we would also learn how to collaborate and partner with key supply chain stakeholders to realize impactful cost reduction. And again, thank you all for attending today's webinar. It is indeed an honor to be here and to share some insights on the large array of opportunities that exist for cost reduction and process improvement and building organizational synergies. So with that said, I would just like to go through a few rules as it pertains to collaboration for supply chain cost reduction. Rule number one, we have to be respectful of the perspectives of our colleagues. This is very important. And we also have to be good listeners, so we practice effective listening skills without interrupting, and we have to be approachable. We have to lead in this way. And we have to ask questions with the honest intent of understanding the interests of our colleagues, stakeholders, suppliers, and customers. And we have to commit to collaboration and continuous improvement and never stop learning about how to improve business synergies and supply chain dynamics. So regardless of the mechanisms that we have at our disposal, mastery of the procurement function, mastery of advanced statistical analysis, mastery of big data analytics, the number one requirement of an effective supply chain leader and procurement function leader is the ability to influence. The ability to influence. So this is, again, the number one characteristic in order to enable us to realize cost reduction impact. So I would like to also start here, and in our course, the 14 purchasing best practices, There's a best practice number 2, I believe, is the utilization of commodity teams. And this is, how should I put it, an assembly of people or leaders in your organization from your upstream or your downstream processes, including your suppliers, your logistics function, your manufacturing leader, and of course your customers, to assemble them into a team which we call a commodity team. And the idea is to ensure that all critical decisions as far as cost and quality and delivery of the critical, mission critical raw material inputs that come into your organizations, that we as procurement professionals are responsible for procuring, that those decisions are made not in silos, but in synergy. And one of the benefits of using this best practice is that it helps to guard against what we call procurement oversight and unintended consequences. But I have a fundamental question with this. If you look at the list of the 3 critical areas, and you see in green at the bottom of the screen, what about new product development decisions? That is a very important aspect of cost reduction and cost reduction synergies as they pertain to the procurement function. And we'll get into that in a bit, but just reflect on that for a minute. So, of course, we have to, in order to realize effective cost reduction beyond price, we have to understand from the customer's perspective, what is value? And value has 3 components. That there is a conversion or a transformation of mission critical inputs from one stage to the next. And there's a physical transformation from this one stage to the next into outputs or products and services that are done right the first time. All the activities associated with this transformation from one stage to the next are done right the first time. And of course, the resulting output or products and services, the customers are willing to pay for them. So it is very important that we understand the dynamics of value, value analysis, value engineering, value creation. The better we are at understanding this, the better we would be at managing our procurement functions, managing our supply chain function, and creating value, and being able to see the big picture on all the opportunities that are out there, that exist currently in our supply chain for cost reduction opportunities beyond price. So, but then I just mentioned the 3 critical components of value and value creation from the perspective of the customer. But then on average, globally, the typical organization, be it private sector government, operates at about 10% value add activities in their process. About 10%. And about 60% of the activities in our supply chain, in our enabling processes across the board, be it our logistics processes, be it our conversion processes, our warehouse operations, even our procurement functions, about 60% of the activities do not add value, meaning that the customers are not willing to pay for it. There's a transformation of what from one stage to the next of what the customer perceives as value, and the activities are done right the first time. So 60%. About 30% of the activities in a supply chain or in a particular process or functional area, about 30% of those activities they're not value-added activities. They do not add value as we just define value, but they're essential components, be they inspection points, mechanisms where we have to audit processes or financial audits or quality audits, etc. And that leads us to about 10% on average. Some companies operate on a lower 5%. Some companies do well, 20%, but on average, it's about 10% value and value added in the typical process and mechanisms of today's organizations, the modern organization. And as we say, Y, or the output, is a function of all of the variables in our supply chains and in our enabling mechanisms and our total business landscape. The output that we get is a function of all of the variables. So price is one variable, one component of supply chain or business operation. So just keep that in mind. And in one of the prior webinars, I mentioned that it's more than price, right? It's our work is more than just getting a good price or a good price point as it relates to value creation and as it relates to cost reduction opportunities. So the sad thing is that most profit and loss statements, you would not see a quantification, an itemized quantification of the waste that exists in organizations, and that is sad. And for those people who are into lean systems and lean management and lean manufacturing, lean product development, we refer to that as the hidden factory. You know, the two operations going on in parallel in our organizations, the ones that we see and the ones that we do not see and we do not quantify. And this is the domain of what we call the waste. So critical targets or essential targets for cost reduction opportunities are defects, overproduction, waiting in our systems, waiting for information, waiting for materials, waiting for decisions to be made. Anybody or any materials are waiting to be operated on. People are waiting for some materials. They're waiting for machines. They're waiting for information. Any waiting is considered a waste. Unnecessary transportation in our supply chain is a huge opportunity, and we're going to go into that a little later on. I want to skip inventory for a moment. Unnecessary motion in our activities, in our supply chain, including our transactional and our administrative processes as well. I'm going to get into that. And of course, excessive processing or what they call duplicated efforts, or where some information flow, a product is touched unnecessarily at multiple points, and those touch points do not add value. And of course, inventories, excessive inventories, a huge opportunity for cost reduction. And if you just look at inventory for a moment and reflect on that, and all of us could relate to that, the unnecessary carrying costs, to reduce carrying costs by reducing inventories and having the ample levels of inventories without running out, and of course maintaining our support of operations and reducing the risk of loss of sale for not having ample inventories on hand, but shrink inventories becoming obsolete, or exposure for expire, especially if you're dealing or you're operating in environments like the food business, where products like dairy have a short or produce, fruits, vegetables have that are used as material inputs to the manufacturing processes. They have a short lifespan. They're risk for exposure. So unnecessary inventories are an evil, and running out of inventories are and also another big issue. But so here are and of course the underutilization of human talent. If we don't utilize our human capital effectively in our operations, in our supply chain, that is also another issue where it could create high turnovers, and we know the cost associated with that. Gallup did some research, and they mentioned that about 80% of the workforce in the United States, they're not engaged in their day-to-day work, and that's something to think about. So all of these here, what you call the 8 waste in business, or what they call the 8 deadly sins, are huge monumental opportunities for cost reduction, opportunities way beyond price. And then we can also look at the same dynamics in this way using what we call SIPOC, suppliers, inputs, process, outputs, customers, which are essentially the components. It's a systems thinking way, or systems perspective, or systems thinking way of looking at supply chains, business landscapes, and operations, that every process has suppliers into the process that feed critical, mission critical inputs. Then there are processes that are converting raw material and informational inputs to create effective outputs of products and services that are delivered to our customers. So the SIPOC methodology and thought process of looking at operations, and I have some critical questions here as we ponder and reflect, and we look to unlock opportunities for cost reduction. So suppliers, are our suppliers, are they a good fit? Are they able to ship on time with the right quantities, the correct inputs? Big question. Our processes, if you look at our processes at the operational level, collectively, our collective process set in our organizations, it is worthy to note that about 60 to 80% of waste, process waste, the 8 deadly wastes that I mentioned, and we focus on 7 in particular, about 60 to 80% of the waste comes from our administrative and our enabling processes, because a lot of organizations have done well with their manufacturing processes to reduce inefficiencies by some organizations, they're able to automate their processes, so they pretty much have taken out a lot of the waste dynamics in their manufacturing process. However, their administrative processes create a big opportunity for cost reduction. Just just for you all to be aware of that. And then if you look at our outputs on the product level, and we apply the 80-20 and the 450 rules, where we understand that 20% of our product line will drive about 80% of our operational and supply chain complexities, and 4% of our product line would also drive about 50% of our supply chain process and organizational complexities and issues. So with that said, something to think about: how often do we rationalize our product line, where we look at our products, we look at our top sellers, and we ask the question, yes, we get X amount of revenues from a particular product, but what is the true cost of having that product? What is the rationale? Do those products need to be redesigned and reconfigured? What is the degree of complexity associated with the supply chain dynamics that encase those products? Do we design for X? And what I mean by design for X, that's a methodology. If we go online and we do our due diligence and we look at design for X, folks who are into engineering, they'll understand this term. Our products designed for ease of manufacture. Our products designed for ease of use. Our products designed for ease of repair. Our products designed with ecological parameters in mind. Our products designed for safety. So all of these here are opportunities. How many times have we purchased products and they're a nightmare to use, or they work well, like some automobiles? I'm not going to call any particular brand. I'm not going to mention any brand in particular, but some brands of automobiles are known to be great when they're working. But when it comes to repair, they're a nightmare to fix. They need special and specialized technicians with specialized skill sets to work on them. So what is the cost of ownership to the customer, and what is the cost of ownership to an organization for owning a product of that product line of that nature? So again, ease of manufacture, or do we design for ease of manufacture? Are the designs for the customer perspective easy to use, easy to repair? Because believe me, once you come to repair and warranty, there are costs there associated as well. So all of these are opportunities. And I'm sure you all see at the bottom of the screen, I put the muffin, right? The voice of the owner and the voice of the customer. And I'm going to give a really quick story. Some years ago, I was working as a consultant for a local bakery in the United States. And the owner, was a big chef, and he said, I'm going to change the whole product line. This is what I need to do. Change the entire product line. I'm going to make the re-engineer the product line. I'm going to make it the best of the best. And I asked him, I said, the changes that you're about to make, are you going to include the customers and ask them, what they want? He said, no, I know what they want. So I advise you against that, sir. I think it'd be prudent to understand if they're declining sales, to ask the customer, what they want, because that would provide critical intel and information on how to redesign the product line. So of course, he did his own thing. And there was one muffin in particular, right? That's why I say the muffin. And he decided to put pistachio nuts on top of the muffins, this particular muffin. And the day that we launched it, right, actually the week that we launched it, the sales plummeted. And I actually observed some of the customers, and I asked the customer, and I noticed he was picking off the pistachios from the top of the muffin. I said, sir, how come you're taking the pistachios off? He said, I don't like pistachios. I don't know why I prefer the old product that we had, the old muffin. I don't know what they did here, and they put pistachios on this, right? And then there was another lady in the store at the time, and she said, yes, I'm also allergic to nuts. So I'm not going to buy it. So my point is that could have been mitigated if we had done a voice of the customer analysis and just asked them what they want, right? So again, Y is a function of all the X's. And what I mean by X's, we see at the bottom of the screen, X's are the variables, the output variables, right? Again, output variables in this case would be design, how the products are designed, ease of use, ease of repair, ease of manufacture, design for ecological impact, and so on. And then you have the process variables, how a process is configured, the process steps, how they design, and of course the inputs that go into the process. All of these are variables, and each one of these variables that in a supply chain, if we understand and we do a due diligence and we dissect each variable, each critical variable, we would see those variables in themselves are opportunities for cost reduction. And we'll also get into those dynamics. So if we're getting a situation where our products are overpriced, we have loss of sale, that is the output that we're getting. Again, go back to the variables in all of the mission critical processes in our supply chain, and the answers are there. So listen to the customers. Again, we listen to our customers and we understand their requirements, and we understand the degree of importance of the customer requirements, and we understand that the customers may require many things from a particular product organization, but to understand that a few of them are critical. And what I mean by critical, if our products and services do not deliver on those critical characteristics that the customers tell us that this is what they want, then our organizations could be in a perilous situation. So critical opportunity for cost reduction beyond price points is to understand, and for us as procurement and supply chain professionals, to understand those customer requirements. If we understand them and we ensure that our suppliers are aligned and capable on delivering on those critical requirements, we would be doing our organizations a service. And then again, these here are critical keys of cost reduction opportunities. Also, too, we should look at our own processes and how we do our own work. And this is a SIPOC mechanism for ordering process, determining the need, communicating the need, reviewing the need, etc., to closing the transaction and to receiving our raw materials. In this case, it's for a theoretical bakery. And if you look at all of the inputs that go into each process step, all of those inputs could be opportunities to reduce cost, because if those inputs are not of premium quality to enable our processes to execute the required outputs, then we would yield some sort of customer dissatisfaction at some level that would erode profitability. So to really understand, and this is a chart that we could use to look at the critical processes in our supply chain and look for opportunities. So the SIPOC methodology, very, very powerful way or mechanism to look for opportunities beyond cost reduction, opportunities beyond price. So a systems thinking approach, the understanding that a business system or a supply chain system is made up of what? Is made up of measurements or system metrics, is made up of materials, raw material inputs, etc. It's made up of processes, machines, people, environment, meaning layouts, and the technology. So there could be many systemic elements in your environment, and to map them out this way and to look if the problems in particular that are not meeting or enabling us to meet our requirements, our mandates, or ultimately of customer satisfaction, then we are able to understand them and dissect them at the root cause level. If we look at things this way, we could see a host of opportunities to improve our processes and our systems and to reduce costs, again, beyond price and price points. Now, this, what we call a fishbone diagram, was a real world situation that was done where we found we were able to realize a huge amount of savings and cost reduction beyond price points. So these were all of the drivers that were driving cost in a particular organization. And I was part of this process. And these are all of the I would say, cost drivers. If you look at machines, high failure rate of the machines, reactive maintenance, lack of preventive maintenance. We look at the environment, limited visual controls, spaghetti flows, meaning how the people and the materials, how they were moving in all erratic ways, poor training, poor workstation planning. All of these were driving a huge amount of cost. Again, beyond price points of raw material inputs. And then we look at the materials themselves. You see lack of supplier accountability. Yes, poor quality produce, in this case, fruits, vegetables, missing, out of stock, lack of procurement accountability. You look at the processes were not designed for urgency. Again, spaghetti flows. I'm going to get into spaghetti flows in a minute. So all of these here were the causes for excessive expenditures, and they were all targeted for cost reduction opportunities. This is another way of dissecting our systems, and each particular system has its own dynamics, but pretty much measurement systems, materials, of course, we need those raw material inputs or those raw materials. Every organization has processes, machines or equipment, right? It will vary from process to process, organization to organization, and people, and some sort of layout. All of these dimensions here, if you want to call them dimensions, are opportunities for cost reduction. And of course, what we call quantifying, or the quantification of what we call the hidden factory. Again, this was an actual process that I worked on in the past, and you could see here, underutilization of labor, right? Process changeover, machine failure. Look at all of the cost. Again, these were all targeted, and these were all what I call non-price cost reduction categories and opportunities. So I want to get into, and I mentioned this in the prior webinar, what we call the 6 big losses in business. And as procurement and supply chain professionals, it is imperative, it is absolutely necessary that we understand these dynamics. And the whole idea of we go back, and I hope you all see the connection that I'm making here, of setting up that commodity team, of collaborating with key stakeholders, with other departments, other functional areas, and not, as procurement professionals or those who are in the procurement practice, not running your procurement function as a silo, to have regular meetings and involvement of your manufacturing leaders, your logistics leaders, your warehouse leaders, your customers, your suppliers, people in finance, the sales and marketing, people in sales and operational planning, to have a team of that nature and continuous collaboration. It is very, very important to maintain that. Is a very, very powerful best practice. So, and to look holistically upstream. And what I mean by upstream, you go upstream to the suppliers, and downstream for the procurement function will be, again, the logistics function, the warehouse function, the manufacturing or conversion functions, to have that collaboration where we don't think as silos, we think at the supply chain as one mechanism, and that we are responsible for cost reduction opportunities. But in particular, the 6 big losses in business, I am of the opinion that every procurement and supply chain professional, every business leader has to have a good grasp and an understanding of this reality. So the 6 big losses in business: equipment failure, right? And the 6 big losses are broken down into 3 critical categories: availability, performance, and quality. Okay, so equipment failure is number 1. That's an availability loss. Big loss number 2, setups and adjustments. We go to set up from, we have to set up from, do a setup and some adjustment from one product to the next, right? This is also a big loss in business, and it's an availability loss. And every time that the machine is idling or there's some minor stops, a lot of times these are created by material jams, inaccurate settings, and I'm going to get into settings, and for misaligned sensors. Those are performance losses. And then reduced speed. For whatever reason, our machines are not are running at optimal speeds. Those are performance losses. And then, of course, defects. The machines and our critical equipment, they generate defects. That's a quality loss. And reduced yield. For those who understand first pass yield, that is also a quality loss. So these are the 6 big losses in business. So if part of that commodity team could be utilized to identify and to quantify the 6 big losses, and that's a huge, monumental opportunity for cost reduction, again, beyond price. These drivers also impact the procurement function, because every time we have low first pass yield and we have a certain level of demand that our customers want, and we're not able we have a low first pass yield, that results in the overutilization and over procurement of raw materials. The customer still wants a certain demand. Customer demand is customer demand. If you can't meet demand, you're going to lose business. So guess what? All the materials that are destroyed from setups, right? Sometimes you're running a new product, and then you have the machine, and you have to run a few to make sure that the settings are correct. And then some of those, then you lose product, right? So this again creates, I would say, overbuying, right? So and there's a huge opportunity, and if you're able to quantify this and identify them, believe me, the losses could be staggering. This plus the 7 or 8 deadly sins or critical waste in business, those 13 dimensions are huge opportunities. With that said, in terms of product development, new product development, and we as procurement and supply chain professionals have to ask ourselves a question: at what stage, if you look at the stages here, stage 1, opportunity identification, concept generation, concept evaluation, the actual product development and design, and then the launch. At what point in the process, or at what stage is the procurement and supply chain function part of these decisions? So my point is that the earlier that the procurement and supply chain function, the earlier that we are involved in new product design and new product decisions, the better off our functions would be, and we would be able to mitigate a lot of risk. How many times I've seen many situations where decisions were made, prototypes were made, and then the procurement folks, okay, now you have to make sure you have supply of XYZ materials, and we are told late in the process, right, after contracts were signed, to find out that the availability of some of those raw materials are not what would not meet demand. And we find this out later, right? And then we have huge monumental logistical problems, and we have huge problems ensuring a steady supply of the critical inputs, right? Again, if we involve early on in the process, again, we have those commodity teams, then we could advise and make the correct decisions and say, hey, that you might have to modify that design, because guess what? The raw materials for that particular design, some of them would not be available on a steady basis, or you've done your research, maybe there's some type of conflict in the zone where some of those materials have to come from, and you could advise on that early in the process and mitigate a lot of risk associated with that. Again, so product development is and doing product development the proper way is another opportunity to reduce costs in the long run. That and the earlier that the procurement and supply chain functions are involved in this process, it could save a huge amount of costs later on. So again, another matter to reflect on: what is our product development process? Is ad hoc? We find out late, okay, you need to make sure you have these such a raw material inputs, and we found out after the fact. And then we somehow have to be magicians as supply chain and procurement practitioners. And sometimes we get into a situation where the designs are not feasible. Remember, I said design for X, design for ease of use, design of manufacture, design for packability, design for effective motion and shipping. So all these design parameters have to be thought out carefully. And if we do a very good design for X, again, do the research on that, we could save and mitigate a lot of cost and risk later on. Again, design for ecology, design for safety, right? We mitigate lawsuits. So again, something to think about in terms of the product development cycles and processes that we have, and to be involved in those mechanisms. And as far as new product development is concerned, to help and to be part of that team that could help improve those processes. This here was a actual dashboard that I made a few years ago for a company, a $50 million company, but the calculation that I made up, or that I realized on the 6 big losses was over $7 million. Now, just think about that for a moment. We talk about cost reduction opportunities. 6 big losses are huge. And if you look at machine 1, right, we see that for every hour that machine was in use for 10 minutes. There's something to think about. Okay, and to understand our OEE in our organizations are very, very, very important. Is what we call the overall equipment effectiveness. Again, if you're in the service sector, you have to translate these metrics and these dimensions to your particular situation. And of course, many of these concepts could be applied across the board: healthcare, service, government, manufacturing. We have to do our due diligence, and the bottom line is that this stuff requires work. So if you just want some quick fix, and you all want me to just give you something here, just do these 2 things, and you just wave a magic wand and all the costs are going to go away. That's not reality. This requires work, study, due diligence, the ability to influence, and to a lot of diagnostics and effort. But if you look at this matrix here, we see the availability dimension that I mentioned, performance and quality, and the 6 areas, and we were able to quantify based on production patterns, the waste and the impacts of the 6 big losses on this particular organization. The OEE, the overall equipment effectiveness, again, a critical metric that, in my opinion, should be on a profit and loss statement. So you can look at cause and effect. A low OEE, how does it affect profitability? On a particular month, the OEE was elevated significantly. It should translate. That should directly translate into a higher degree of profitability. So we have to sort of rethink the manner in which we look at our financial statements, our balance sheets, our profit and loss statements or mechanisms, our cash flow mechanisms. We have to rethink that. Our OEE of 85% is considered world class. World class. That would mean that the availability is of our equipment, our mission critical equipment, is 95%. The performance, right, is 95%, and the resulting quality coming off of the line is 95%, right? So 95%, 95%, 95%. That is only equal to, doesn't average 95%. That's an OEE of 85%. The calculation is availability times performance times quality. That is the calculation for OEE. So to have an OEE, overall equipment effectiveness of 85%, is indeed a very, very tall order. But so I recommend that you all start here and you look at the 8 waste in your processes and your systems for cost reduction. So you look at it internally. You could go downstream to your customers, help them out as well, because if they have those situations going on in their systems and they have a lot of waste, it's going to impact you, right? It's going to impact you and your organization. If your suppliers have the same issues, right? Suppliers have the same issues, it's going to impact you as well. It's going to impact essentially your price, right? Your price. So to look at this totally. So again, the SIPOC suppliers, you look at it, what they give you those inputs, you look internally into your organization, all of the processes, including not only your conversion processes, your manufacturing processes. When I say conversion, I mean manufacturing, or the conversion of raw materials into products and services. You look at the non-manufacturing processes as well. Some experts say up to 60, even up to 80% of the opportunities are for cost reduction are in those enabling and transactional processes. With that said, again, the 6 big losses are a critical dimension for opportunity. Changeover. This was actual improvement on a changeover process that project that I did, and we were able in our first wave to reduce changeover from 27 minutes on a line fulfilling it's a soup manufacturing plant, and they had the massive kettles where they produced the soup, and then the output or the soup will funnel into what they call fillers that filled the different bags and containers of product, and it was taking up to 27 to 30 minutes on average to clean the lines and to do a changeover from one product to the next. And in the first wave, we had gotten it down to 8 minutes, from 27 minutes to 8 minutes. And that we were able to realize a huge amount of money there, savings. And on the second wave, we had gotten it down to, I think it was a little over 7 minutes, and then eventually we had gotten it down to 6.5 minutes. And those two improvements after the first improvement came from people on the line by listening to them. Remember when I started and I said the ability to influence. So to realize this here, right? A lot of times we think cost savings and we think improvement, organizational improvement, and then we're like, oh no, that's going to be too difficult, you know. Oh, that's theory. And you make all these excuses, right? It's theory, and you know, that's too difficult. It's not going to work. That's not going to work here, right? So again, breaking down those silos and those bridges by the community, the commodity team, listening to people at all levels in the organization, getting their input, and really understanding their position. So again, the first wave was 8 minutes, then we got it down to a little over 7 minutes, then 6.5 minutes. And those two improvements came from ideas from people on the line, by myself and management, listening to those people. And we were able to influence them to be part of the change, right? Because people normally resist change. So we were able to influence them. And after that, we were able to use the tools and the mechanisms and the methodologies to improve the process. So again, root cause analysis, doing things and approaching cost reduction at the root cause level. Many times we realize that there's some problems and cost reduction opportunities, and we just jump to a solution to reduce the cost of a particular problem, and we didn't study, we didn't do our due diligence, or for whatever reason, to realize why those problems were occurring, to understand the root causes, and then we had what you call a reoccurrence of those problems, and the initial gains were overrun by the problem reoccurring, and sometimes some problems reoccurred at a bigger magnitude, so we actually made things worse. So to understand issues and these systemic issues, to understand the interaction of, remember I said that the input variables, the output variables, the process variables, dissecting our systems this way and studying them, and looking for the interaction and the cause and effect and how those variables impact each other. You know, simple analogy, if you put baking soda and you add water, you put those two variables together, you're going to have a reaction, right? There's a cause and effect, right? There's a reason why that, you know, if you put baking soda and you put water in it, there's a bubbling effect, right? So the same thing with business systems, and you know, we have to understand and study these dynamics. So to understand issues at the root cause level, so this way we could design and formulate solutions and cost reduction solutions to address them at the root level and to eliminate once and for all certain issues. So again, to approach cost reduction from a root cause and a systems thinking level, it's very, very, very important, especially if you want those cost reductions to be sustainable and to stick. So part of the analysis that we did, again, we did due diligence, and we found that the reason why changeovers were taking so long is we had 3 operators on the line, and you look at these jagged lines here. This was the way how the people were moving. You know, I was on the floor and I studied each person and how they would move around to do a changeover, right? And the distance that they traveled. No wonder it took 27 minutes or 30 minutes. And you know, you had the management on the floor, you know, pushing the people, come on, you have to move faster. So then I said, you're moving them, you wanted to move faster on a wet floor. You know, I said, have you had any injuries? Yeah, sometimes, you know, people slipped and fell, you know, but they have to move faster. I said, but, so you want speed and you want accuracy of work. So the other matter is a lot of times we run away from problems and we love to use this. Oh, that's theory, or that's not going to work, because the mere fact that someone would say that a problem could be fixed. Oh, that's not going to work. That's in theory, yes, but I'm a practitioner, so yes, I've studied theory, but I've also applied many theories. And this happens to be one of them. So there was a demand for speed, right, to reduce the change over time. But there was also a demand for accuracy. So then I had the person from quality came and said, well, we have to make sure this is a food environment. We have to make sure that whatever they're doing is done correctly, right? And so this way we would meet the food safety requirements. So they should actually take their time and do it. So the quality person was, I don't care how long it takes, right? So then I said, well, the business cares how long it takes, because if it takes too long, the business would not be here because should be out of business. So she said, well, either you want to do it faster, or it has to be done accurately, and it has to be done accurately. So you can only have one or the other, because they contradict. So we have a contradiction, right? She said, yes. So I said, well, we have to make it work. She said, that's impossible. I said, no, it's not impossible. She said, what do you mean? We can't get speed and accuracy at the same time. They contradict each other, they oppose each other. I said, well, this is, I've been doing this for a long time and dealt with many issues like this. I said, look at this, right? Look at this, what we call spaghetti. You see all these lines, we call it spaghetti. So I said, well, if we reduce the spaghetti and we reduce the distance traveled to do certain tasks, then we will take time out of the process, right? She said, yeah. And then it'll be done more quickly, yes. She said, yes. And I said, then they could pay more attention to what they're doing, because they're making mistakes here anyway. There were still certain mistakes that were made, and it was taking long, a lengthy time. So bottom line is, we were able to get it down to 6 minutes and 30 seconds. And we had 100% compliance, food safety compliance, meaning that every step in the process was executed correctly. And guess what? The employees did not have to move faster. So we were able to re-engineer the process, we analyzed and we studied where the inputs that they needed, the materials that they needed to execute that changeover, where they were located. And this process was not designed for speed. And if you look to the left of the screen, you see grease. You have to clean certain parts of the machine. You have to grease them, and then if you look to the left there, you also see you need a squeegee and a shovel to clean the elements of the floor. And you look at the distance that these people have to travel to get their materials and the inputs to execute this changeover. This is what was consuming their time. So bottom line is, we were able to put things at point of use. We were able to mix certain kits, and we were able to assign each operator to a certain zone where they only had to move a certain amount of feet, and they had all of the materials that they needed within a couple feet of their position. And this is how we were able to realize speed, less stress. They were executing each process step around the same time, the same way they were doing it before. And we were able to have them work in parallel as opposed to series and executing the process steps. And yes, we were able to take a huge amount of money out of this supply chain. This was a huge cost reduction opportunity. And guess what? It reduced the wait time for the next in line product to come through the process, because 27 minutes, 30 minutes to do a changeover on a fill line in a soup manufacturing plant. That means that for 27 minutes, product is in a hot kettle, and quality is being compromised. There were many times where we lost yield because of overcooking and products sticking to the walls of the kettle. So there was yield loss when we were doing the changeovers in the fill line in 27 to 30 minutes. And as we reduced that timeline, the yield actually on was increased, and as well as the quality. Here's where we studied each of the time elements of that changeover process, and we were able to reduce the time. Also, too, in terms of equipment, to reduce equipment failure, total productive maintenance is a methodology in which you would involve the operators of the machines to execute certain functions in terms of cleaning the equipment effectively before they actually start their production run, and after they start their production run with a checklist to check the condition of the equipment, and it's a process to if they see anything wrong with it depends on how those checklists are designed. They see anything wrong with the equipment, they're able to report those issues early on before there's an equipment failure. I've seen situations where equipment is broken and people on the line say, well, oh yeah, that stuff was happening 2 months ago. So they knew for 2 months, and they didn't say anything because there was no process to facilitate that. And now the maintenance crew, they're running around trying to get the equipment up and going, and equipment failure is a huge opportunity. We saw from the OEE case that we did there, that we looked at that slide, as a huge opportunity for cost reduction, again, outside of price. So this was actually a real project that we did, and we were able to reduce equipment failure by 85% using what we call total productive maintenance. Again, we could do our research and study that methodology. Value stream mapping, as I mentioned, looking for opportunities, and we look at where products are in the production cycle. We look at one of the powers of the value stream map is that it looks at the informational flows. It looks at the different stages in the product relative to time, and looks at the cycle time, the actual time it takes to execute work in the process. And you will find that if you do value stream mapping, you will see that from one process to the next, in this case, like cutting, then printing, then binding, and final inspection. In between the processes, sometimes products would sit an inordinate amount of time, and that time, those time elements are huge opportunities for cost reduction. I remember seeing a process, and it was to make wire baskets. There was a customer that, and this is a real situation. Every few months they would order 10,000 wire baskets, and it took about 45 days from order to the delivery of those wire baskets. And the organization did a value stream analysis, and they analyzed using value stream mapping to look for where the time was being consumed. They also did the spaghetti analysis that we went through, and we saw how the materials are moving all, and there's a humongous plant, and how at the different stages in the process, from, for example, cutting to the next stage, it moved all the way across the plant. Then it has to come back another way to go another section of the plant, and they analyze all of that, and they re-engineered the process, and they got it down to 4 days. From think about that, from 45 days, they got it down to 4 days from order to delivery, right? So value stream mapping is another huge opportunity and mechanism by which we could find cost reduction opportunities, especially in terms of time. So we have to understand time elements and the impact of time and cost. Again, as we mentioned in the last webinar, customers want things cheaper, better, faster. Again, the triple constraint. And yes, we could realize, we could make products that are delivered more quickly, delivered with speed, speedy processes, a higher quality, and cheaper. We can. If you take the waste and you take the big losses out, you take those dimensions out of the process, you look for those and you capitalize on those cost reduction opportunities. The excessive amount of time that we spend in non-value-added activities, we redirect a portion of that time to focusing on what adds value and the value-added activities, and we find ways to improve even the value-added dimensions in our processes. We make those more efficient. Products could be made cheaper, better, and faster. So this is not theory. This is all in practice. It's all a function of focusing on the 8 critical wastes and the 6 big losses in our organizations. Also, too, relative to time, understanding what we call TAC time, or the TAC. It's a German word for tempo, and it refers to the rate at which a product or service needs to flow through a supply chain or through a process, and it's underpinned by customer demand and the net available time to execute those processes. So the TAC time, in this particular situation here, we see that the TAC time requirement, meaning customer demand and the window, the net available time to execute that demand, was 22.93 seconds, and this was a real situation. And there was only one operator on this line, or this production line, if you want to call it that, that was meeting on the TAC, and that was Jill. The other 2 folks, Jack and Jason, could have been considered the bottleneck in the process that brought the store average or the total average to above the TAC requirement. As you see, the store average here was 33.8. Again, this process was not meeting customer demand and created a whole chain of problems that we mentioned in the webinar. So to be able to do the calculation, to do the analysis, to understand bottlenecks, what a bottleneck means. A bottleneck is essentially a bottleneck or constraint. A constraint is essentially a process, person, a machine, or whatever that is above the TAC line. So to be able to calculate that TAC line, TAC time, understand and draw the TAC line and look at each process in your environment to see the constraint or the bottleneck processes. And the idea is to, in those bottlenecks, there is money. Because in this particular situation, this was a chain of 27 locations, and this was a project that was done at one of the locations with the idea of transporting the findings to all 27 stores to improve the way that they were meeting customer demand and customer satisfaction. We found in this case, the store, by not performing to TAC, they had huge loss of sales, line buildups, and loss of market share, eroding market share. And once we were able to fix this situation, it made things a lot better and yielded tremendous cost savings and improve customer satisfaction. So to be able to calculate TAC time, again, customer demand divided by net available time, that's your TAC time, and to be able to chart it this way, draw the TAC line and look for each what they call dimension that's above the TAC. There's money in there. This could also be done at the process level. where you have different processes or process steps. So you can do this at the different levels, at a macro or micro level. So you could do it at the process level, for example, procure, manufacture, ship, right? Those are 3 processes. Then you have your what you call the TAC, or the customer demand, X amount of units, right? And you look at those 3 processes, and you understand the net available time, you understand the customer demand, and you look to see which one of those processes are the bottlenecks or the constraints, right? And the idea is, if you have a constraint, you have a bottleneck, you have loss of money, you have loss of cash, you have poor customer satisfaction, the greater the magnitude of the bottleneck. And the idea is to attack those bottlenecks and bring them down to takt time. If you're able to do that, it directly affects profitability, right? So we were able to do this. Again, right, we saw Jason and Jack, bottlenecks. We were able to study, right, what was occurring when they each serve that they made, and we were able to understand what was causing the bottlenecks and consuming the time, and them disabling them from meeting that takt time. And we were able to bring them into the green zone, where you see Jill, she's primarily in the green zone, and this entire store was able to realize enhanced productivity, profitability, customer satisfaction. The customers were very, very, very happy about it. The employees were very happy, less stressed. Very, very great experience. And again, to be able to quantify waste and to dissect our processes. This is a hybrid of a SIPOC that also includes, so it's a mixture of SIPOC, the SIPOC chart that we went through earlier, and a waste audit mechanism to see where the time elements are being consumed in that location. Actually, they were 20% value add and almost 66% waste in the process. And we were able to, again, to re-engineer the process and to eliminate most of the waste, or much of the waste we were able to eliminate. And this resulted into bottom line, increased profitability. And we get in towards the end, cost reduction by risk mitigation. Again, the procurement function is a 3-fold mandate to manage spend, support operations, protect organizations from risk. Manage spend, support operations, protect organizations from risk. So cost reduction, yes, could be realized by risk mitigation. It could be realized by error proofing on your processes. In Toyota or in Japan, they call it pokayoki. Yes, error proofing, and it's part of a risk mitigation strategy. Failure model and effect analysis, a very powerful tool for doing this, where we would look at how a process could fail, or a product. You could do it at a process level. So it's what they call process FME, process failure mode and effect analysis. There's what they call product failure mode and effect analysis as well. So you can look at it at different levels, and you look at it, you analyze it, products and processes in terms of how they could be in a mode of failure, and what is the impact of that mode of failure, with the intent of prioritizing these failure modes into what we call a risk priority number, meaning the higher the risk priority number means that that a particular product or process or element of a product or element of a process is of a higher risk point to an organization than one with a lower risk priority number. Again, the formula for risk priority number, which is the underpinning of the failure mode and effect analysis methodology, is severity times occurrence times detection. So severity meaning the degree of what you call it, of impact and how severe that is on the organization and first and foremost on the customers and the employees. The severity, and you rank it on a scale of 1 to 10, higher meaning it's more detrimental. The degree of occurrence on a scale of 1 to 10, how often does a product element or product or process element or process fail, how often it occurs. And then the final the critical dimension of a failure mode and effect analysis methodology is the ability to detect. The higher the number means that if you have a detection and scores, detection and dimension scores 10, it means that there's almost virtually no way that you could detect that the product or service or process is going to slip into failure. So the highest risk priority number would be 1,000. 10 times 10 times 10, and this is screaming, please fix me. This product is a potential hazard to the customers and employees and the public at large, or the process. Again, the lower the number, the better. And each industry has what you call acceptable limits in terms of what a risk priority number would look like. Again, this was actual FMEA, that part of FMEA that was executed in the field relative to missing ingredients in the materials category. And then we looked at the effects of the failure we see here: great delays to production and filling process, getting ingredients in late and still frozen in a frozen state could damage the what you call the kettle agitators. This was in the soup environment. What you call the pad, the mechanism to turn the soups while it's cooking. They call it the agitator. So the whole premise was that if you get late deliveries, because you're missing ingredients and getting deliveries late, sometimes certain materials like meats and stuff that come in and they're frozen. If they're not thawed properly, they could damage these agitators. So again, looking at the failure mode, right, which would be potential failure mode, missing ingredients, as we see. Effects of the failure would be great delays to production, getting in ingredients late and still in a frozen state could damage the agitators, which is another problem, and the shortage of products and products to customers and loss of sales. So these are what they call the effects of the failure. And then you look at the root causes we actually determine, and the current control levels or power levels, and we see that this particular issue, it was actually 800, which was screaming that it needed to be fixed. Immediate action was needed. We were able to reduce this, and again, tremendous cost savings was realized as a result of fixing that process by using failure mode and effect analysis. So we see, again, be part of solution design as procurement professionals. Again, don't operate in silos. Be part of that commodity team that I mentioned before, and to be part of solution design. Don't point fingers and blame other departments for issues. And to understand these dynamics are very important. To understand first pass yield, all of the things or the drivers of the excessive use of materials, be there the 6 big losses that we mentioned, that actually unnecessary setups, machines that are not properly maintained and generate a lot of defects would create a situation where it could create a cost overrun. And would enable or mandate that us as procurement professionals procure excessive materials than really required to meet demand, and this erodes profitability. So to understand these dynamics, why, how come they ran out of just replenish the stock levels on certain material inputs? What happened? Demand didn't increase. Why are we running low on stock? Well, it could be that you have some of those losses, right? So to understand these dimensions are very important for us as procurement professionals, and to be involved in them, and to look at cost reduction beyond just the price for what we pay for the material. So I hope I was able to convince and to be helpful with this webinar to my dear audience that there are huge opportunities for cost reduction beyond just beating up our suppliers on price. So if you're able to collaborate with them, I've been in situations where some of my suppliers had very excellent world-class manufacturing processes, and we brought them in. Hey, could you come in and help my production team, my manufacturing team improve? Could we collaborate? And I've done that a couple of times, and we realize tremendous cost reduction. I remember one situation I was responsible for, in addition to being director of procurement, I was responsible for the warehouse operation. And there were some issues going on in the warehouse that it was a cost driver. It created a lot of cost, unnecessary cost. And I looked at one of my suppliers. I said, well, I noticed your warehouse operation is like top class. Could you send a couple of your guys over to me to train some of my guys? And that was done, and we realized a huge amount of cost savings. I remember in particular, they helped me reduce the time that we spend receiving product and offloading trucks. We were able to slash the time by 75% and to meet the food safety requirements. But that's first and foremost. And that was a huge cost reduction, initiative and realization on many levels, I had less damaged product. I had product that was less reduce the exposure of products, especially in the food environment, sitting out on the dock for too long. We were able to again, 75% reduction in the receiving process and the time it took to receive, to offload and to receive trucks. And we had a dramatic, I think it was like 90% actually reduction in food safety non-compliance issues. So again, to analyze our systems way beyond the parameters of the price of products, and collaborating with our customers and our suppliers to look for opportunities to balance supply and demand dynamics, to enable value creation. The opportunities are it's an ocean, and the idea is it's tempting to try what we call boiling the ocean, right? Again, as I mentioned before, focus on the 80-20, the 450, the 4% of the process elements or processes that drive 50%, or where 50% of the cost savings elements reside, or the 20% of processes or products, or what they call it, systemic factors. Remember, machines, products, process, technology. Looking at the 20% of those systemic factors that could drive 80% of your cost reduction, and again, the 4% of those systemic dimensions that would drive 50% of your cost reduction opportunity. So the idea is to laser focus and not try to boil the ocean and to be everything to everybody in every way. It's not that is not practical, right? And again, not backing down from contradictions, There are many things that are business contradictions, engineering contradictions, technical contradictions, and sometimes those are the demands of the customer, right? That's just how they want it. Like a customer wants something big and they want it small, right? So we can say, oh no, that can't be done. It's impossible. Yes, it can be. You could have a product that is big and small. That could be done. There's a tool and there's a caveat called TRIZ, T-R-I-Z, right? This is the methodology to deal with contradictions. So with contradictions, I don't back down from contradictions. I don't back down from contradictions in business, right? If you go online and you type in TRIZ, you will see that they're what they call 39 contradictions in business and in engineering and products. There are 39 contradictions that you're going to face. A lot of times they come in pairs, and there are 40 inventive principles or solutions to solve those problems. So big and small, they're contradictions, right? And you may be in a situation where something has to be big and it has to be small at the same time. How is that solved? How is that solved? Segmentation. You ever saw like a big ruler that could be from here and it goes out 30 feet and you could fold it into itself and collapse it and make it small to put in your pocket? So the person who was the first person to say, I need something big and small, people look at them as, hey, this is not, it's impossible. Yes, so TRIZ. And the matter of contradiction, of speed and accuracy, we face this a lot. We need speed, the element of speed, but we need accuracy. So sometimes we push people, right? Why do you want things done quickly? Because time. Remember I said time and cost, right? No, but boss, if you're pushing me faster, I'm going to make mistakes. Well, the customer wants it and the business requires it. Speed and accuracy. And so we put our hands up and say it can be done. Yes, it can. If you go on YouTube, type in IndyCar racing, and you see speed and accuracy executed with monumental precision and excellence. Speed and accuracy. The solution, the inventive principle and the solution for that is prior action. So a car pulls up into the pit stop, right? Car pulls up into the pit stop, and in seconds, the car is out. 4 tires change, oil change, the driver gets a drink, right? And the car is out in a matter of seconds. If you look at it and you rewind those tapes, you see that each wheel and each tire and each person, all the tools were in position before the event of that car pulling up into the pit stop. Prior action is the solution, the inventive principle as it relates to the methodology called TRIZ, Theory of Inventive Problem Solving. It should be TIPS, but it's a Russian acronym. TRIZ. Please do your research on this and do not back down from contradictions. So speed and accuracy solved by prior action. IndyCar racing. And yes, the changeover, to get the changeover from 27 minutes to 6.5 minutes, we use those concepts. And we dealt with the speed and accuracy contradiction. So that is it for today. I hope it was helpful to you all. I'm going to be here for a little bit to answer any questions that anyone may have. If you have any questions, could you please type them up for me, and I'm going to review questions, and I hope you all enjoyed it. And of course, please make sure with your cost reduction initiatives, you do your return on investment analysis, you do your cost benefit analysis. This was a project that I worked on. The target was 1 million. We realized close to it, almost $900,000. We were able to realize with this project a few years ago. So to make sure you do your cost benefit analysis. So I'm going to be here for any questions that anyone may have. Let me see. Oh, I see. Okay. Hi, you have a question? Who's this? At Adobe?
No, No, hi.
Hi, how are
Sorry.
you?
Hi, I'm fine, thank you. I'm
Please
hoping
step
to
on that.
get the slide for today's
Oh, okay.
presentation. Thanks.
Not a problem. Do you have any questions in particular? Because I know a lot of this stuff. It sounds.
Very mathematical.
it, it, I'm sorry.
It sounds a bit mathematical. It's a lot. There's a lot of calculation that goes into. I mean that would that goes into this the analysis that you presented, really.
Of course, of
But
course. Mm-hmm. Go ahead.
yeah, but I don't have any questions for now. I just need to because I was on and off, so I just need to go through the slides, So,
Not a problem. Not a
mm,
problem. As far as mathematics is concerned, what I showed today, a lot of it is simple math. Addition, multiplication, just
mhm,
the simple math. There have been projects where I had to use very, very advanced analytical tools to determine analysis of variance and chi-square and those things, those issues. So there have been situations where I had to deploy those mechanisms, but a lot of what I showed today, yes, there's a lot of analysis, but very, very simple math. For example, the I mentioned about looking at what they call unnecessary transportation or motion in a process, right?
yeah,
So the way this was done, right? I
mhm,
had I had my stopwatch, and I had the process itself, all the steps in the process, and I looked at each operator, right? How long it took them to do each function. So start, stop, and then I recorded that. Start, stop, I recorded. And I did like about at least 9 to 12, what do you call it, observations of the same thing. Because
mm,
sometimes if you just do one observation, it could be a slow one or it could be a fast one. You know what I mean? You don't get the reality. So I did about 9 to 12 observations of the same thing, right? And then
yeah,
in Microsoft Excel, it just calculated the time it took to do each, what do you call it, step in a process and how much time the person was in motion. So if I see someone, for example, I was talking about the changeover, right? And I
mhm,
mentioned that part of the changeover is to after you clean certain mechanical parts, you have to use food safe grease, right, on them so they work properly. So, but the grease was located at 40 feet from the machine. That meant that the person the operator who was responsible for getting the grease had to travel 40 feet to go and get it, and then 40 feet to return it. So when I studied, that what they call motion and transportation in the process, right? I not only calculated the distance that the person had to travel, how much time. So when I saw the person moving, okay, it took him X amount of seconds to go to the grease, the area where the grease was located. And it took him
mm,
X amount of seconds to return it. And then I just added all of this stuff up. So it looks like a lot, but it's simple math. The key is to understand, as I mentioned, all of the components that go into your business, right?
mhm,
And my dear, if you take a post-it, the post-its, right? And
yeah,
you write
sure,
down everything that you do to do work in this one process, and you put the post-its on a wall, you will be surprised what you see. Just to do our own work, to generate a purchase order, if you really, really, really take a post-it and you do everything that you do, you'll be
mm,
surprised what you see, right?
mm,
And the whole idea is to ask yourself, what is redundant here? What is not necessary? Sometimes we do things based on old business rules. You ask people, right, especially in manufacturing environments, well, why are you doing so and so? Oh, well, since I came here 5 years ago, this is why we're doing it, right? And guess what? A lot of times those rules are not no longer relevant, So
Right.
the idea is to simplify the things that consume time
Fine.
and that
Okay.
don't add value, because those things, my dear, drive cost. You see this
Mm.
thing, this matter of the 6 losses in business.
Yeah.
Oh,
Mm.
so for this company, $50 million, over $7 million in losses as a result of the
Wow.
accountant, the chief accountant, his jaw dropped, and we did an
Mm.
audit.
Mm.
Yeah. So I mean, outside of, so me in my practice of procurement, yes, I want a good price, right? But
Right.
what do we want it for free, right?
Mm.
So there comes a limit. After you get that the best price point, if you open our eyes and we look around, there's so many opportunities for cost reduction. There's so many. It's for for small organizations, for big, and the thing is, a lot of times people say, "Well, we'll just buy equipment," right? But I just give an example of equipment. The place was mechanized, but again, the equipment was not optimized. The equipment was in disrepair. The settings weren't always appropriate, right? Um,
Mm-hmm.
so they still had a lot of start, stop, and the equipment, all this mechanization, right? With all the mechanization, right? And one of the
Mm-hmm.
machines, every hour it ran for 10 minutes.
Mm.
So
Wow.
a lot of companies can't afford these
Wow.
equipment. In
Wow.
America, 80% of businesses are small and mid-sized. They can't just afford to
Okay.
go and spend $1 million to go on and buy a piece of equipment. It's in many
Mm-hmm.
emerging countries,
Mm-hmm.
many countries and emerging continents, they can't afford huge expenditures just to go and buy
Mm.
equipment. If you're going
Yeah.
to buy the
Yeah.
equipment, make sure you're using it properly. Make sure that you mitigate and you minimize the 6 big losses, and that we are aware as procurement folks, right? How many times I remember so many times buying raw materials. I'm like, they use those materials already. They come to, oh, we're almost out. How do you mean you're almost out? And I look at my demand. Demand didn't change, right? So I will
Mm-hmm.
go to the floor because I'm also a process engineer. So I go to the floor and I look at everything, and I'll say, okay, now I see why you all are consuming so much material. Now I understand, because I'm able to go to the machines and then do my own diagnostics. 'Cause a lot of times people wouldn't tell you, they're scared. So
Mm.
to be able to influence and to be able to speak to people and make them come to you and say, hey, Mr. Dave, the reason why we use these materials is because of so. And the idea is don't explode on the people, right? Just talk to them and collaborate with them, and
Mm.
they'll tell you, they'll tell you. So this is some very, very powerful stuff. So I hope for all the procurement folks who are in the webinar today, where they're so hyper focused on price, I hope they got a rude awakening with this stuff here. There's an ocean
Mm.
of stuff.
Mm.
60%
Yeah.
of the activities don't add value to what we do. 60% on average.
Wow. Wow.
Huge amount of money and materials and times consumed in those categories, right?
Okay.
So a
So
lot
what?
of go ahead.
Okay. So basically, this sort of scenario kind of
Yep.
like it paints a picture of what happens in the manufacturing industry, right?
Okay.
That's the
Right.
supply chain in the manufacturing industry. So a situation like where I am, I'm in the telecommunication industry
Uh-huh.
sector. We don't
Yeah.
do all of this, right? So it's just basically the core procurement. So I'm just wondering, how can I apply this sort of
Ah.
this 6 service in a service-based procurement, supply chain scenario on
Uh-huh.
for under the telecommunication sector, you know?
Okay. Mm-hmm. Okay.
Yeah, so
So your question is, are these concepts applicable, correct? Yes, they
yes.
are. So one of the reasons a lot of the webinars I do, I use the
Mm-hmm.
example of the soup serve service. It's a
Okay.
service. So and this was a real world situation of a company that has a manufacturing plant, right? That they manufacture their own soups and they ship those soups to their stores, their location. There are 27 locations, right? So the customer would come, the end user, the customer would come, and you would serve, they'll come to the store and they'll buy their soups, right? So you have, each store has a counter staff, correct? They have a counter staff where they serve them the soups. The customer will order their soups and they'll serve them the soup. And then there's another section where they'll pay for the soups, right? So this is customer service. This is a service, and this is the service component of the company. And there's a reason why most of my webinars, I refer to this for that same question. Because a lot of times we think, no, this is manufacturing. No, I focus on both areas. So my point is, and I mentioned before, 60 to 80% of the opportunity for cost reduction are in the transactional space in our organization. So if you have a manufacturing organization, correct? An organization is a manufacturing organization. 60 to 80% of the opportunity is in the non-manufacturing processes. This is what I'm telling you. Because a lot of companies, they're very good with the manufacturing process. They do the automation. They weed out a lot of the inefficiencies. But all of the other processes, the accounts payable, the accounts receivable process, the accounting processes, the human resource processes, they're all broken. And most of the waste and inefficiencies are in those processes. And a perfect example, government processes. Oh my God. So my point is, if you go back to the slides, right? Was it? Did I do it? Yes, with Jack, Jill, and the other person, they were serving soup. They weren't manufacturing the soup. They were serving the soup. The manufacturing was done at the plant, right? So same concepts were applied. Right, the same concepts were applied because the customers, right, the standard was 30 seconds, I serve you your soup. They were above that. One guy was about 43 seconds. This was a real situation. I just changed the names. It was a real situation, right? So of course, a lot of times the line will build up and the customer will look and say, no, I'm going to the next to the competition, and they were losing sales. Right, so I was able to identify, right, what was causing this person, right, to be at 43 seconds, and it's very easy as the manager's like, come on, speed up. That didn't work. Do you know what that did? That made people quit. It made people quit. Right, so it made people quit, and now you get a new person, you got to train a new person, and then you make the matters worse. So we were able to use the same tactics, the same strategies, and to see what was causing the excessive amount of time. And in 2 weeks, I fixed that problem in that location. 2 weeks.
Wow.
2 weeks, I fixed that problem. And again, influencing and involving the people, listening to them, and getting the buy-in. So I asked the guy, I said, one of the guys said, how you feel? He said, oh, Mr. Dave, I'm stressed out. I said, I'm here to help you. You work with me, I work with you. Right? I'm going to observe your times. Don't feel nervous. You just do your job. So I made him feel comfortable. I said, okay, you have to work on this. There's a chart there that I was able to pinpoint all the reasons that were consuming time in that process. That time, that excessive time, again, resulted in line buildups, loss of sale, loss of profitability. There were many times where they were expecting to sell X amount of soup, but they couldn't move the line fast enough. Now, once you put the soup out, if it's not used, at the end of the day, you dump it. So then the procurement folks who are buying more and more say, hey, we're buying more and more. We're not realizing the sales. What's going on? You're not selling that much. Well, you can't move the line, so you're wasting. Right? So again, that's an example of a service environment, and the concept was used. That's why I put those slides, and I'll continue putting them there. So you could apply this in the service sector and in manufacturing. For example, people who are accounts payable, for example, how many times do you see emails back and forth? back and forth all day, back and forth, right? That's email, that's informational spaghetti, back and forth. It looks like it looks like spaghetti in your pot. How many times you see people wait? What am I waiting on? What are you waiting on? Oh, I'm waiting for Mr. Dave for this and this and this and this. Okay, and then you see people moving around. You know, and then how many times in the same process people touch something more than once? You need 5 people you need 5 people for a signature. For what? Right? And then and you need X amount of people to make a decision. So you're over processing. That's a form of over processing. How many times we generate? How many times in the transactional space we generate reports that nobody reads? That's overproduction, right? Right? And how many times the errors in reports? That's a defect. Same concept applied in what you call the transactional space. In healthcare, how many times you go to the hospital, you wait for 2 hours, just to see the doctor, and you see the nurses, they're moving around like this, up and down. You draw. This was done in the hospitals too. The slide that I did, webinar I did last week, I focused on the healthcare space, right? And you do the same thing. You draw the path of the nurses, moving from here to here to here to here. I'm going over here. I can't find this one. I have to go over here. I have to wait for this. I have to wait for that. Oh, I need these materials to perform this treatment on a client. I'm sorry, on a patient. And I have to wait. What you have to wait for? They have to replenish the stock levels. You're out. So now you have to replenish. Now the patient is waiting. Same thing. Waiting, motion, transportation, over processing, defects. Right? And you see the nurses moving around like this, and suddenly they make mistakes. How many times did you hear about situations they operate on the wrong arm? Right? Or they make the wrong same thing. Same concept. Same concept. So the value stream mapping was also a lot of hospitals are using it. Do you know that in the American healthcare system there's almost $1 trillion, yes, $1 trillion in waste? Do you know that?
No, I didn't. Wow.
$1 trillion annually in waste. There's a book written by J. Arthur. J. Arthur, book written by J. Arthur, right? Lean, I think the name of this is Lean in Hospitals, or Lean Healthcare by J. Arthur. Get that book. Some estimates say about 500 billion. Some estimates say about 700. I think the most reliable estimate is about 1 trillion. But even if you go at $500 billion in waste in the healthcare space, and then that's a whole different issue I want to get into. But yes, in healthcare there's huge amount of waste from those same dimensions. The machines in the healthcare and in the hospital, the machines, right? They also have the 6 losses as well. If the machines are they don't work effectively, the same thing, right? Or you're going from one patient to the next, and you have the setup and all of these things here, right? All of those things impact time. They impact time, and the machines don't work effectively. Then you get an incorrect reading, and they give you the wrong diagnosis, and they have to go and do it again. Think about that. So the machines also too, the equipment, right? You remember I said you dissect your environment. So if you're in a hospital, right, you look at what do you have in your hospital, right? You have machines, you have people, you have process, you have the materials that you use, right? The materials, if they're not rotated properly, you could be using certain materials that are expired. So many things could go wrong. So in your space, in your environment, in telecom, you have processes, you have measurement systems, you have people, you have materials that you use, you have equipment that you use, you have informational flows, you have technology. All of those things drive cost, right? The next major problem that you have, right? If you look at one of the slides, you'll see that I use the fishbone. On the head of the fish, you write out what's the problem. You write out what's the problem, how long is occurring, which process, how much is costing, what the fiscal impact and the impact on the customer. That's a problem statement, an effective problem statement. How long something has been occurring, which process, right? What do you call it? The impact on the organization and the customer. A problem statement. The problem statement, one of the things not to do with a problem statement is to say, well, it's because this person didn't do what you're supposed to do. You don't assign blame because you don't know. You have to determine the root cause. You have your problem statement and say, okay, what is surrounding this problem? Are there people? Yes, you put people. Okay. What else? Is there equipment? Yes, you put equipment. You have process around here, documented or not? Yes, there's a process. Are we measuring performance in this environment? Yes, you're measuring. You put all those systemic, dimensions, right? And then you investigate which ones of those are contributing to the problem, right? And once you dig deep, you'll see huge opportunity to reduce costs and to eliminate problems. So yes, and you will see the same 13 dimensions, right? Actually 14, 8 waste and equipment issues. Because in telecom you have equipment that you use to do your work, right? Correct?
Yeah.
There's
sure.
equipment. Okay, if the equipment doesn't work properly, what happens? And equipment could also be your computer systems. All of the equipment.
Downtime. It leads to downtime, loss of time, and of course that's.
So how many times? If equipment is not working properly, then you have people waiting, right? What are they waiting for? The equipment to work properly, right?
Exactly. So time gets wasted.
Okay. So now, if you have the wrong information, right? Information is an input, right? And you feed your process the wrong information, then what happens? You do the wrong thing, right?
If I feed in the wrong information, yes, the output becomes distorted, really.
Okay, now you have to rework, you have to do it over again, correct?
Yes.
Right. So that means the first time, that means you yield. Same thing as in manufacturing, your first pass yield. In other words, your process to be profitable has to yield a certain amount of conforming whatever it is your output is, right? And we just give a scenario that if you give the wrong information, for example, you're going to get the wrong output, correct? Then you have to do it over again. No, to do it over again, does that cost money?
Oh, yeah, sure.
Now, if you calculate that now and you determine, okay, how many times we do correctly what we're supposed to do, that's one way to look at it. Another way to look at it is how much rework, how many times we have to do things more than once. In other words, we have to do something 3 tries to get it correct, right?
Right.
And what's the cost of that? What's the cost and the causes of that, right? So you go back to when I started off. Value has 3 components. It's done right the first time. There's a transformation from one stage to the next. Step 1 with this information, step 2 with this information, step 3 with this information, and you could actually see the value is building to the output. Correct? It's not cum fire cum, it's in stages. So there's a stage, there's a transformation from one stage to the next. It's done right the first time and the customer is willing to pay for it. Again, if it's not done right, is the customer going to pay you?
No.
Right, so then you have to do it over, right? So value has 3 components.
Yeah.
So again, the same concepts that we spoke about in your environment. And you mentioned time. The value stream mapping it pinpoints your time. It looks at your cycle time versus your lead time, right? How long does it take to do so and so? Oh, 2 weeks, right? how much work is done. If you look at the cycle time, to do so and so and so, it takes hours sometimes. Why is it taking 2 weeks, right? You remember I gave this scenario, and it was not it was a real story about the wire basket company. I can't say the name. 45 days from, hey, can I get, there's a customer, every few months they order 10,000. They have the limit, standing order, 10,000 wire baskets, right? 45 days to deliver. Sometimes if they make a mistake, it could be 60, 70 days. So once that whole environment, the process was re-engineered, the layout was reconfigured, the machines will sequence a certain way, right? They got it down, right? To 4 days. 4 days delivery. Right? So so yes, so the value stream, it looks at the lead time and the cycle times, and you'll be surprised. Sometimes it's quick to do something, but it goes from one process, it stops, it sits. Then it goes to the next process, it sits. You see those sitting times consume a lot of time. A lot of time. So yes, there is a value stream map there on the slides for healthcare, and that whole situation with Jack and Jill. That's I just had to rename them Jack and Jill, but that's in a service environment. And there's a reason why I put that to answer your question. This is not only for manufacturing environments. Okay. So I hope that was helpful to you. Shoot me an email and I'll send you the slides. D Millington, Millington, MILLING at nextlevelpurchasing.com. So D as in David, D Millington, MILLINGTON at nextlevelpurchasing.com, and I'll send you the slides. Any questions you have now that you have my email, in terms of how to apply these concepts to your place, let me know. I've worked in big environments, mid-sized environments, and very small environments. And over the years, I've learned how to modify the concepts based on whatever environment I'm working in. Okay. All right. No, thank you so much for attending, and I hope you enjoyed the webinar.
Yeah, it was good.
Thank you so much. Anybody else has any? Thank you. Anybody else has any questions? Hi, Yvonne. Hi, how are you?
So how are you? About bringing people current in time, and do that from starting from a blank slate, not walking through how.
Hello. Hello, Yvonne. Hello.
I've done this. Where does this come? But if you joined us for a lunch and learn session where we have a global launch.
Okay, I'm going to send you the slides, Yvonne. I'm going to send you my email address. .com. Okay, thank you very much again for attending today's webinar. It was very exciting and enjoyable, and I hope that you enjoyed it as well. And if you have any questions, you have my email, dmillington@nextlevelpurchasing.com. If you have any questions on the material and how to apply the concepts at your workplace, shoot me an email, and I'll be more than happy to assist. We are very Next Level Purchasing Association, very, very, very passionate about what we do and helping you as procurement and supply chain professionals succeed in what you do. And yes, the concepts that we went over today are applicable to the different industries, healthcare, government, service, as well as manufacturing. I'm working on completing the SPSM 4 series, and I'm working on the senior executive leadership course, and we're going to be touching on different environments. Again, thank you very much for attending today's webinar, and have a great day.